video for AQA Mechanics, Work, Energy and Power, section 1.1, where we're looking at the idea of work. Work is done when a force is applied to an object and the object is moved through some distance. The work done is a scalar quantity and is defined as follows. The work done is the force multiplied by the distance moved in the direction of the force. Now we're considering these to be constant forces at the moment, and we'll later look at what happens if we have a force which is variable. However, for the moment, the work done by a constant force is the force multiplied by the distance moved in the direction of the force. The units of work are Newton meter, force multiplied by distance, but this is more usually called a joule. So 1 joule is equal to the work done when 1 Newton moves through 1 meter. So Newton meter or 1 joule. Well, we should note that work can be positive or negative, so that although it's a scalar quantity, then work done which is negative is going to mean that something is going to lose energy. See that again in the connection between work and energy in a later video. So if we're moving from A to B with a constant force, then we could look at a force distance graph, and we can see that we've got the area under that graph. And that's how later we will look at the idea of what happens when we have a variable force. Now, just because a force is acting on something, it doesn't necessarily mean that work is going to be done. So we have to have some movement. So for example, here we have a weightlifter, but if the weights aren't moving, then the weightlifter is not doing any work. So now just a couple of examples using the idea of work is force multiplied by distance moved. So in the first example, we've got a sledge which is being pulled across smooth ice. Now smooth is a modelling thing, which means that we've got no frictional forces. So smooth is really used as a mathematical modelling tool to say that we can ignore any frictional forces. They are negligible compared to the 45 Newton force that we're pulling with. This is if the sledge moves a distance of 10 meters, how much work has been done? We know that work is force multiplied by distance moved, so then this is simply 45 multiplied by 10, which gives us 450 joules. In the second example, we've got a box which is being moved up a slope with a force of 200 newtons, and the height that it moves through is 2 meters. Now that 2 meters is not in the direction of the force, so we need to first of all calculate the distance that it moves along the slope. So the distance along the slope is given by the hypotenuse of the triangle. So we've got sine 30 is 2 over d, so sine 30 degrees is equal to 2 over d, and therefore the distance d is equal to 2 over sine 30. Sine 30 degrees is a half, so therefore d is equal to 4 meters. The work done is force multiplied by the distance moved, so F multiplied by D, and that's equal to 200 multiplied by a distance of 4 meters, giving work done here of 800 joules. That's the end of this video looking at work. In the next one, we'll be looking at the idea of kinetic energy.